And that's where we are going to discuss about access management. We already discussed we can do a lot with IAM users and roles and give them permissions to actually perform operations on AWS resources. But the biggest question that arises here is, how do we actually do that using IAM? Yes, we can do that by using IAM policies. Let's read this. You can manage access in AWS by creating policies and attaching them to IAM identities or AWS resources. You must understand that policies in AWS are nothing but JSON documents that are attached to an identity or resource, which helps to define the permission. I have repeated this 3 times now for you to understand. For example, if you create an IAM user and that user wants to create an EC2 instance, by default, the permissions will be 0 or denied. Until and unless you attach an AWS EC2 policy to that user, he or she will not be able to perform the desired operation. Remember that. Now let's check how does a policy look like. Here you can see we have optional top level element. Then we add statements as per our requirement. We can also add an optional policy wide information at the top of the document and one or more individual statements. We'll discuss the example, don't worry, I'm just giving you an overview of how the policy looks like. And the most important thing to remember here is that each statement includes information about a single permission. If a policy includes multiple statements, like we have here statement A, B, and C, AWS applies a logical OR across the statement when they are evaluating them. If multiple policies apply to a request, so if suppose this is the policy, there can be multiple policies like this and which are applied to a single request. In that case also, AWS applies a logical OR across all of those policies when evaluating them. Let's check this statement by expanding it. Each statement information is contained within a series of elements like SID, that is statement ID, effect, principal, action, resource, and condition block, which is also called as the PARC model. If you see PARC, you have to remember it in a way. You have the principal, you have the action, you have the resource, you have the condition block. It's not that you will be using all these 3 entities every time in a statement or a policy, but you have to remember when you're talking about a JSON policy or IAM policy, you always think of the PARC model. It's easy to remember. PARC, that is principal, action, resource, and the condition block. We will discuss each of these terms individually. For now, just think about the PARC model. I know I haven't explained these terms in detail, but don't worry, we will discuss in depth, so keep watching. As I've already told you, each statement includes information about a single permission. So each statement that you have here will be having information about a single permission, whether it is allow or deny. If a policy includes multiple statements, as I already told you, like there can be multiple statements, then AWS applies a logical OR across all the statements when applying or evaluating them. So statement A or statement B or statement C, the logical OR. If multiple policies also apply to a request, AWS applies a logical OR across all of those policies when evaluating them. Similar to the statements, if there are multiple statements, we can have multiple policies also attached to a request. That time also AWS applies a logical OR across all those policies when it is evaluating them. But before moving forward, we need to watch this segment again. Do you now understand who can access what? Who is the identity? Can access is by using your IAM policies. What is the AWS resources within your organization? You might be thinking, why am I pushing these terms onto you repeatedly? It's because when you think of IAM, you should always ask who can access what. And by using this principle, you'll be able to analyze how things should be designed and with respect to any use case that you have. So you'll be able to analyze and design with respect to any use case that you have, considering the AWS IAM or user provisioning or users access management. Now let's discuss the elements that make up for a policy statement. The first one that we have here is version. We can specify the version of the policy language that you want to use. As a best practice, use the latest version, 12, 10, 17 version. And we write JSON policies, and that we will discuss in some time. These are basically called a policy language. And you're meant to write the policy in a certain way for it to be acceptable by IAM. Next one is the statement. We use this main policy element as a container for all the following elements. You can include one or more than one statement in a policy. This is something that we already know. So the statement contains the elements, policy elements. So as I already told you, we have SID, effect, principle, action, resource, condition. So these are the policy element or the statement elements. So next one is SID, which is an optional element. So SID is also called a statement ID. So here we can include an optional statement ID to differentiate between your statements. And this is optional, but if you have multiple statements in your policy, you can add a statement ID or SID to differentiate the statements. Next is effect. This is very important because by using effect, you allow or deny permissions to indicate whether the policy allows or denies access. And here, if you write allow for this effect, then only it will be able to grant permission for the resources to be used or operated. And if you write deny, the user will not be able to use the resources or the resource that has been mentioned as a part of the policy. The next one is principal. So a principal is a person or application that can make a request for an action or operation on a AWS resource. If you create a resource-based policy, you must indicate the account, user role or federated user to which you would like to allow or deny access. So let's suppose you are creating a policy for a S3 bucket, which can only be used by a principal user or account. Then you must provide the principal of that IAM user or an account. So a principal is nothing but the Amazon resource name, that is ARN, that you already know about. We will discuss that as well, don't worry. So you provide a ARN as a value of the principal. So principal is nothing but a person or an application that can make a request. Next, if you are creating an IAM permission policy to attach to a user or role, you cannot include this element because the principal is implied as that user or role. And if you bind it to a particular user or service using the ARN, the whole purpose of this will be defeated in certain use cases. So remember, a principal is a person or application that can make a request for an action or operation on a AWS resource. If you are making a request as a user, then you are the principal. Next is action. It includes a list of actions that the policy allows or denies. So you must first understand that with effect, we tell the policy if it should allow or deny. So effect tells the policy whether you should allow or deny. But we also need to provide the information on what levels they should be able to perform the operation. For that reason, we use action. As its name suggests, you provide the list of actions like it should be able to, either it should be able to read or write or delete or perform get request or put request. All this is called an action for a particular policy. So I'll give you an example here. Let's suppose the effect is allow and the action is to punch. So if I am supposed to punch you, I can only punch you if the effect for me is allow, which allows me to punch, and the action is mentioned that you can punch. So action is you can punch and effect is allow, then only I can punch you. So if the effect is deny and the action is you can punch, then I cannot punch you because the effect is telling me that the policy does not allow me to punch you. So you must understand it in that way. So one is the effect which actually allows or denies the request, and the other one, the action, is telling you what action you can perform. The next one is resource. Now that you know how we are performing the operation or how we are allowing the operation or denying the operation, so if you create an IAM policy, you must also specify a list of resources to which the actions apply. And if you create a resource-based policy, this element is optional. If you do not include this element, then the resource to which the action applies is the resource to which the policy is attached. For example, you want to operate on a S3 bucket. Then you will provide the S3 bucket ARN as its resource. So a resource is an object that exists within an AWS service. Example include an EC2 instance, an IAM user, and an Amazon S3 bucket. So the principal is the one requesting the action, and resource is the one on which the action is going to be performed. I hope you got the difference here. I'll give you the same example again. Let's suppose I am going to punch you. So I am the principal, you are the resource, the effect will be allow, and the action will be punch. So if these 4 conditions are satisfied, that policy will allow me to punch you because I am the principal who is making the request. You are the resource on which we are going to punch, and the action will be punch and the effect will be allow. If the effect is deny, then I cannot punch you. The next is condition. This is also an optional element because at certain point or policy we want to add conditions so that it applies to a certain specific condition level or a certain specific use case. But a condition specifies the circumstances under which the policy grants permission. And that is why I said it is going to satisfy a specific condition. So let's suppose you want to check if this request actually comes from a certain IP range. Then you can add a condition with IP address with a particular CIDR block. When you add that condition, you know that every request that is going to come from that particular IP CIDR block, or every request that comes from any source will actually check whether that request comes from that particular IP range, and if it does, then only it will allow it or deny it. So let's see this example here. This is a resource-based policy. Don't worry about what a resource-based policy is right now. Just look at this example, which has explicitly deny all principals except for the ones specified in the condition element. So you are denying all principals. Let's suppose you have 10 members in your class and you want to allow or you want to deny everyone from accessing the resource other than the one mentioned in the condition. First thing is version. As I already told you, specify the version of the policy language that you want to use. As a best practice, we use the latest 2012-10-17 version. Next one is statement block. Here we have only one block of statement enclosed within curly brackets, and within this statement block we write our policy. So this is our policy. The first one that we have here is the SID. It's optional value, but we have given it a string called use principal ARN instead of not principal with deny. So this is another way of defining a principal. Don't worry about this. Just remember that that is a string and we have given it as a SID. Next is effect, which is deny. So you're denying the permission. So effect is deny. Remember that. Next is the principal, which is star. Star means you are allowing all principals. Just think about this. You have the effect deny and the principal is saying that it is for all the principal. So till this point, the policy is telling that deny all access to all the principals. On what action? S3. So S3 star, which means it has access to all the bucket operations. So all these principals which are denied access had the action that they could perform on all the S3 bucket operations. And what is the resource on which they could perform the operations? Is basically bucket name / star. That's the bucket name and the bucket name itself. The first one is for the object level access and this is one for the bucket level access. So bucket name / star and bucket name. And last but the most important part comes the condition block. Here you can see we have a condition block called ARN not equals, within which we have the key as AWS principal ARN, and within that we have the ARN of that particular user or the particular principal, and ARN AWS IAM the account ID user / username. Let's suppose this is your username. If ARN not equals to this particular username, deny access. Okay, because that effect is deny. So this condition tells us is that all the principal except the one that is in the condition block doesn't have access, and that is why it's denied. As you can see here, we have the park model, and that is why I had mentioned that if you create a resource-based policy, you must indicate the account, user role or federated user to which you would like to allow or deny access. I know at this point you may not have clear idea on what this type of policies are, and that's what we are going to discuss next, and I'll tell you how you can identify them. So let's move on. But before moving forward, I know some of you will get confused with the term ARN or what we call Amazon Resource Names. So I want to discuss this, and I want to discuss this so that you know why I am referring to principals and resources as ARNs. So when I use the term ARN, you should be able to identify that. So what is an ARN? Amazon Resource Name or ARNs helps us to uniquely identify an AWS resource. So these help to uniquely identify an AWS resource. So what are the resources itself? The resources could be the user or any service like EC2, its instances, its volumes, a bucket object, or even a Lambda function. The reason why ARNs are used is when you need to explicitly define granular permissions to a particular principal or a resource. That's why it is rightly mentioned here that And that is why it is rightly mentioned here, we require an ARN when you need to specify a resource unambiguously across all of AWS, such as in IAM Policies, Amazon Relational Databases, and API calls and tags as well. Unambiguously means a clear statement of a particular purpose. And if you aren't aware of this word, it means like other synonyms of these words are explicitly, clear cut, or definite, or specific. So we have to define them specifically, then we use the ARNs. Now let's see the format of ARN or the syntax. We have three formats on display. So we have here ARN, partition, service, region, account ID, resource ID. And similarly, we have resource type / resource ID, resource type : resource ID as well. Now let's understand each term individually. Let's suppose this is our AWS account, and each account is hosted on a specific AWS partition region. Like we have AWS, AWS-CN, AWS government, and this is the partition. AWS is for AWS region, AWS-CN is for China region, and the third one is for the AWS government cloud US region. So this is the partition, and this entry will be given in place of the partition that you see here. Next we have the AWS region area. For example, we have US West 2, AP South 1, and so on, based on what region you are hosting your resources. These are your region codes. So it will be replaced with this particular region. Next is when you create an AWS account, you get a unique account ID, and in ARN, you should mention the account ID without hyphens like this. If you see this on the AWS Management Console, you will see them with hyphens, but you have to mention them in the ARNs without using hyphens. Next comes the service part, which is a service prefix list like S3 or EC2 and so on for other resources. So this is the service prefix, and this comes in place of the service element here. Next, we have the resources themselves, which have their own resource identifiers. For example, the resource identifier that we have for IAM users will be user / John Doe. And for an EC2 instance, it will be instance / I hyphen the letters that we have, that is for the EC2 instance. And there will be a syntax of resource types : resource name : qualifier. And when we combine these to form ARN, they look something like this. The first one is ARN : AWS : AIM. So AWS here is basically the partition, IAM is basically the service, and : account ID, that is 1 2 3 4 5 6 7 8 9 0 1 2, user, that is the resource type / development / product _ 1 2 3 4 *. And this actually specifies all IAM users that are a part of the path _product _ 1 2 3 4 using a wildcard as follows. And if you also had a requirement, we could have also specified user / to mean all users, or if suppose you want to include all groups, you could have also mentioned group /*. That means for all groups. The next one is ARN : AWS : S3 : my _ corporate _ bucket / development /*. And this is an ARN for S3 bucket path, my corporate bucket / development, and all objects within development, as we have a star next to that. Next is ARN : AWS : EC2, and we have the region name mentioned here, US West 2, and then the account ID : the resource type, that is instance / the resource ID. This is one of the examples. Here you can see we have the ARN for the EC2 instance with the region, account ID, and the resource type and resource ID. Lastly, we have ARN : AWS : IAM with account ID : U star. And next to that, you can see we have mentioned it is not allowed. Why is it not allowed? Because you cannot use a wildcard in the portion of ARN that specifies the resource type itself, such as the term user. User is a resource type because user is a resource type in IAM ARNs, and you cannot use wildcards with resource types. So make sure that you don't do that when you are forming a ARN. So you must be careful about this, and this is how we uniquely identify a resource and how we want to attach permissions for a resource. So let's move on. I hope you will remember what are ARNs. ARNs are basically used to uniquely identify AWS resources. Now let's see another example of writing IAM policies. How to grant access to an Amazon S3 bucket. Here we see we have two statements within the policy. As I have already mentioned here, we have two different ARNs to specify bucket level permissions and object level permissions. Now let's see the first statement. Here the effect is allow. The action is S3:list objects for the resources, that is ARN, as ARN:AWS S3 test. It means that we allow a list object operation on the test bucket. So the name of the bucket is test and we are allowing list object operation. The first resource element specifies ARN AWS S3 test for the list objects so that applications can list all objects in the test bucket. So this is clear. Let's see the second one. The second resource element specifies AWS S3 test /star for get object, put object, delete object actions so that applications can read, write and delete any object in the test bucket. Here as well, the effect is allow, which means that it can allow, or it's an allow operation on the resource test /star. So here you would ask me, why have we divided these into two parts? We could have written all the operations for both bucket level and object level permissions like test star, and we could have minimized the code. And even though it is a valid question, let's see why we have written it like this. If you see the first statement here, it precisely specifies allow permission for the list object, and this returns some or all up to 1000 of the objects in a bucket. So that's basically to list the objects. But still, we did not combine the two ARNs by using a wildcard such as test star, because even though this ARN would grant permission for all actions in a single statement, it is broader and grants access to any bucket and object in that bucket that begins with test, like test bucket or testing, because we are using a wildcard that is test star. And that is why if you write test star, this policy would apply to any bucket that start with test, like testing, test world, test dev, tested, testify, and so on. And this example might sound stupid right now, but let's suppose you make this small error and eventually you will end up messing the data that you wish to collect. Or if suppose in any case, if you apply this and you accidentally apply a delete using this policy, you might be aware of what might happen next. Now that you're aware of this, let's see how it actually looks like in real time. And thanks everyone for joining in for today's session of AWS. I hope you got some of the information that you wanted. And if you haven't subscribed already, then please do so. Please comment and like the video. And that really helps me a lot and helps the channel grow and is a really motivating factor for me. So please make sure that you subscribe. It really takes a lot of work and a lot of hard work to actually bring in these videos. So please make sure that you support the channel by subscribing and liking the video. So I'll meet you in the next session of AWS. Stay safe, stay healthy. It's Pythoholic signing off.